In this video, we're going to be talking about evaluating and improving your model. So there are 6 steps for evaluating and improving your model. And we are going to be talking about steps 1 through 3 in this video. So let's make a simple model, and we'll use the example of the food system. So we've created a simple mental model using the mental modeler software of what we think the food production system might look like. And this will be our exemplar model for the rest of the video. So thinking about systems and systems modeling, we want to evaluate the dimensions of model, particularly the structure and the function. So what is the structure of a system? Well, these are the parts of the system. So we can think about the structure as, does the model include all of the important components? If not, what is missing? And are there components that are superfluous to represent the system? We can think about the function of the system as how the defined structure and behavior of the system interact together to influence the overall dynamics and outcomes. So when you are running a scenario, or you're increasing or decreasing a component, does the overall system state make sense? If not, evaluate the structures and behaviors that you defined. If they are correct, then you have a surprise. If they aren't correct, you need to revise. And that might be changing the weights or the directions or the connections or structures and repeat the scenario. Let's look at the structure first in our exemplar model. Consider the structure of our exemplar model for a moment. The model structure, we can think about it in many ways. We can think about it in the total number of components, the number of connections, the density, the ratio of connections to components, the number of driving components, the number of receiving components, ordinary components, our complexity score, and our top 3 most central components: food production, environmental health, and economic health. When we're evaluating our model structure based on these criteria, we can think about, does the model include all the important components? If not, what is missing? Are there components that are superfluous to represent the system? Now let's look at evaluating the function of the system or the model in our exemplar model for this video. So looking at our exemplar model, we can evaluate the function by asking ourselves, based on the structure, what would happen if we increase the pesticide? So if we are considering the function of this model for a moment, what we could do is increase the pesticide and run a scenario. So this is a scenario output that you might be familiar with from the previous video in the mental modeler software. So when we increase pesticide, is this what we would expect to happen under that scenario? We see here that we have a slight increase in social equity and cultural appropriateness. Is this what we would expect to happen when we increased pesticide? Perhaps the other components behave how we would expect them to, but maybe these 2 components do not behave how we would expect them to. So we need to go back and consider the structure of this model for a moment. And we look at the ways that the relationships are defined. Is there something missing? Are these relationships correct? Maybe something is missing that would make the model more accurate based on your understanding. So now that we've talked about steps 1 and steps 2, we want to think a little bit about steps 3, which is thinking about parsimony. So what is parsimony? Parsimonious means the simplest model or theory with the least assumptions and variables, but with the greatest explanatory power. One of the principles of reasoning used in science as well as philosophy is the principle of parsimony, or Occam's razor. Other things being equal, simpler explanations are generally better than more complex ones. So when that relates to us thinking about evaluating models, we have two models here, but in the theory of parsimony, which model is better? The left one or the right one? Well, the right one certainly is simpler, but is it a better representation of the same system? Or is the left model, though it looks more complex, perhaps a better representation of the system? In the next video, we will talk about evaluating and improving your model, steps 4, 5, and 6.